Good morning, class. Well, actually, I guess it's afternoon for you by now, since this is your homework. You're going to do lesson 7.6, dot products. Dot products are dealing with our vectors. So last section we dealt with our vectors. Our vectors were u and v. And so basically we dealt with those vectors and we talked about those vectors that are in little triangles here. We talked about the two, like let's say it was 2 and 3. Then we were doing A and B, right? So it's going 2 and in the right direction and 3 up, and that's how you would find what that vector is, right? Now what we're going to deal with in this section is how we're going to deal with these when it comes to multiplication. So dot product means if I have vector u and vector b, v, and I multiply. What is the product of that? And this is the product. So this is what you'll have to memorize. So it's dot product uv equals u absolute value, v absolute value, they multiply together, times cosine theta. Okay? uv cosine theta is what you're going to end up with. All right? Now, how do we get that? So let's think about that. What is the absolute value of u? So if your u and your v has numbers, I'm going to put them in, -3, 5, and 1, 3. All right, and in this problem, they're going to give you your theta as 49.3, okay? So we're going to start, there's our problem, or 4.4, sorry, 0.4. So how would we find what the absolute value is? Well, here's what the absolute value is. Ready? The absolute value of u is going to be your square root of your a squared plus b, right? So a is -3 squared plus 5 squared, left with 9 plus 25. That's the value of u. So the absolute value of u is going to be the square root of 34. Okay, so there's your first one. So you find the first one, which is the absolute value of u. All right, so everybody see that. So far we're in good shape. Absolute value of 34. Now, what do? We need to find the v. So we're going to do it right over here. Absolute value of v, which is going to be equal to a squared plus b squared. So our a is 1. Our b is 3. So what are we left with? 1 plus 9, square root of 10. So the absolute value of v is equal to that. Now, we have our absolute value of v, I have our absolute value of u, now we plug it in to our equation. So, absolute value of 34 times the absolute value of 10, square root of 10, cosine 49.4. So, these are all numbers that can be put into a calculator. Put that number into a calculator and you get the answer of 12. Okay? So once again, to find your absolute value of v, which is your r, right? Okay? It's your r, which is your modulus or your hypotenuse or whatever you want to say it is. You find your absolute value, plug it in, cosine to theta, and that's how you would solve that. Now, another way to solve this very problem is if they gave you this dot product, and what they're going to say to you is this. If it's uv, that's another way to solve this. It's a secondary way to solve this. And what you would do is uv equals ac plus bd. Now, you say, well, what is ab and cb, and so on. Here's what they are. U is A and B. V would be C and D. Does everybody follow me? So if I wanted to use this second method, I would plug them in. -3 parentheses times 1 plus D, which is B, which is 5, times 3. So, somebody help me. -3 times 1 is 3, good. Negative 3, sorry. Plus 5 times 3 is 15. Negative 3 plus 15 is going to give me the answer of 12. Notice how they work out. Now, if you look on the page, you will see that they show this work, okay, on here. We're not going to show you how to solve that. You just need to make sure that you know how to use that. All right? So there's 2 different methods to solve this problem. One using the theta and one using just simply plug and chug. So you have 2 methods. The dot product method. The other one is using, it doesn't have a name, but just another way to solve that equation. All right, so there's 2 different ways, solve the same thing, solve the same, so get the same area. Now, so let's solve another one. Let's practice. All right, I like practicing. Okay, so if they gave a problem to us here of u is 0, 4, and v is 4 to the square root of 3, 4, and the theta is 60. Okay, so let's solve these, okay? Let's solve these. First one. Okay, first one. So we're going to solve it both methods just for practice. Solve the first one this way, all right? Here we go. So we need to find our absolute value of u, which is square root of 0 squared plus 4 squared. So the absolute value of u is 4 squared, which is equal to 4, right? So far we're good. Then we need the absolute value of v, which is going to be square root 4 square root of 3 squared plus 4 squared. So do the work here. So it's going to give me 3, so 48 plus 16. Add these together and you get square root of 64. So that's going to equal 8. So our v and our u are whole numbers, which is nice. Now let's plug it into our first equation right here. So u times v, which is what we're solving, absolute value of 4, absolute value of 8, cosine 60. Well, class, what is cosine 60? Use your unit circle. Cosine 60 is 1/2. So 4, absolute value 8, times 1/2, answer 16. Now, let's check our work by using the second method. So, once again, u has a and b, v has c and d. So a, which is 0 times 4 to the square root of 3, plus 4 times 4. Well, this is going to be 0 plus 16. Final answer, 16. I don't know which way is easier. They're both pretty easy, but, you know, all things considered, that's how you would solve them. So, think about this for a second. If I have lines or vectors that are at a 90-degree angle, if I have vectors that are at a 90-degree angle, that would mean that they're perpendicular vectors. So a vector going this way, I'm sorry, one arrow. Vector going this way, that's going to be a 90-degree angle. So cosine 90 is what is cosine 90? Class, according to your unit circle, is 0. So anytime you do a unit UV and multiply it by 90, or have it at the angle of 90, it's going to automatically just disappear. It's going to make it 0. Now, that's called, they use the word for perpendicular vectors, 2 vectors that are perpendicular. So the 2 vectors that are perpendicular, they use the word orthogonal. Orthogonal. So, what we're going to solve for here is how to find what an orthogonal vector would be of another one. Okay? So, once again, if they're perpendicular, then what's the final answer for any perpendicular line that has 90 is going to be 0. So you got to remember that, 1, because that's going to come in handy. But if I ask for the orthogonal vector, it is a vector that is perpendicular to the other, and this is how you would solve it. This is how you would solve it. So here we go. So if it's going to come out to 0, all right, so orthogonal, another word you need to know, orthogonal. orthogonal. Okay? Orthogonal. Okay? So if I give you a vector u, and it's -3, 1, it's going to ask you this question. So what is the orthogonal vector? Give me an orthogonal vector. So in other words, a perpendicular vector. It's another way to say it, but this is what they say is orthogonal. Now, how would I solve it? If I use this, a, c plus b, d, that is always going to equal what? 0. Why? Because it's orthogonal. It's going to go together automatically. Is everybody following this so far? Are we good? So, if I can plug in an a, which is -3c, plus 1d equals 0. Subtract d from both sides. D equals -3c. Any questions? So are we good so far? All right? negative d, negative. So that's the case. We're really left with d equals 3c, right? So any number we plug in for c, what's our d going to be? 3 times more. So let's say that I pick c to be 2. What's d going to be? 6. So my vector that is going to be perpendicular to this vector is going to be 2, 6. So now, it's not the only orthogonal vector, because any number you put in for c is going to be perpendicular. So in other words, this vector, watch carefully, is 1, 2, 3, and 1 up. So it's going to go like this. Is really what it is, but it's going up to here, so I'm going to just do it there. So the next vector, you want something that's perpendicular. So it goes 2 over 5, 6. All right? See? Look how perpendicular that is. That was pretty close. Okay? All right, does everybody see how that works? So if I plugged in 1 for c, it would be 1 and 3. So there's multiple answers, but that's the goal and that's the desire there. All right? So how do you identify an orthogonal? Is if the two vectors that you put together, these two vectors, will give you an answer of 0, then it's going to be orthogonal. All right? All right, good. Last type of problem for this section, 7.6, is they say, hey, we want you to find the angle. If they want us to find the angle of cosine theta, what would the equation be? So cosine theta equals u times v over u absolute value times v absolute value. Now, does everybody agree with that? So now, what are our absolute values? Our absolute value of u is really r of that vector. And the absolute value is the r of that vector. Okay? And so what you're going to do here is you're going to have to use both of these equations. You have to use these two and this to solve this. So let's practice here. So u is going to be -3, 4, and v is going to be 1, 5. So we're looking for the theta. So we got to start with our absolute value of u. So what is it going to be? Negative square root of -3 squared plus 4 squared. So 9 plus 16 square root of 34, right? So far, everybody's good on that? Okay. Then, sorry, I misadded. I'm 34, 25. Then, absolute value of v. What's that going to be? Well, here we go. 1 squared plus 5 squared. So that's going to be absolute value 26. So we got two answers, right? Plus 5. All right. Any questions on those two answers? So now we just plug it in. So what is this going to be? We're going to have to use the ACBD, right? So the AC, which is, so what's A? A is -3. So -3 plus times 1 plus 4 times 5 all over 5 times the square root of 26. Anybody, any questions so far? So this, because remember, we can substitute this to be AC plus BD, right? Now what? You're left with -3 plus 20 over 5 times square root of 26. So now what do? 17 over 5 square root of 26. We can solve that for a decimal. And the decimal is going to be 0.866. Or I'm sorry, 0.668. Now, remember, we're looking for theta. So this is equal to cosine theta. So cosine theta equals 0.668. If we do that in our calculator, do the shift button, you're going to be left with 4811 degrees. Okay? So, 3 equations you're going to need to know. Dot product, the second dot product equation, and how to solve for theta. Those are the 3 ways you're going to learn what you're going to do in lesson 7.6.